Good morning, dear students. Hope you are doing well. In the previous session, we have seen the topic image enhancement, where you learn various enhancement techniques like image magnification, image reduction, contrast enhancement, in that linear and non-linear contrast enhancements, filtering, transect extraction, color composition. All comes under the umbrella of image enhancement. Now, we are entering into the next topic of the same unit, that is image classification. See here, we are classifying. We are classifying what? We are classifying an image. How can you and me can classify an image? On what basis? For suppose, if you want to classify an image of your classroom, you have to have the knowledge on all the attributes that lies in the classroom, within the classroom. So what I'm saying is, you are the boys are one class, girls are one class. Within the class, if anything classification is taking place, boys, girls, tables, dustbins, board, fans, and whatnot, everything has to be covered. They are in the image. That image you are classifying. What all existed on the image, you must classify. As all classes are similar to each other, most probably there might be a difference of count if one class and another class picks are comparing. But the same objects will be fine. Same boys, girls, same tables, blackboard, faculty, podium, fans, and everything. The similar equipment you may be observed in A section and B section. Similar in the sense, not same, I'm speaking similar. Boys and girls, they're also there. Tables, podium, fans, and all. Now, how can I classify this remote sensing image? Before you are attempting the classification process, what is the need and what is the definition? See here, the definition is there. The process of extracting information classes from a multi-band raster image called as image classification. Yes. It's a procedure to categorize all pixels of image automatically into land cover classes. Land cover in the sense, whatever on the land, whatever covers the land. If it is with water, that is water class. If it is vegetation, it comes under the class of vegetation, like that. Now you got connected now, hopefully. See here, it's a procedure to categorize all pixels of image automatically based on the algorithm into land cover classes. So far, you have seen, what you have seen? Simply the digital images. This is the digital image, right? This is the digital image, right? Now here 56 is there, the digital number, and 85 is there. Here you are able to identify only the digital numbers, but you may not know what it is, what in that location of the image, whether it is a water body, whether it is a vegetation, or else any soil category. Representing these pixels with the categories called as image classification. How can you represent? Have a look here like this. Here is a number, but here it is in a forest class, and here is a water class, and somewhere soil classes. That means urban classes. That means what I am speaking in this context is, what is image classification? It's a procedure. It's a procedure to categorize all pixels of image automatically into land cover classes, so that it will be useful to the end user, and he can immediately understand what existed in that particular location, what existed in the top corner of the location, whether it is a water body, and bottom corner whether it is in a vegetative body. Instead of numbers, if you are able to give the land cover name, that will be more beneficial to the end user. Am I right? I told you on a classic example given in your 3-2. As you are going to ATM for withdrawing money, the moment you inserted card to the machine, one pop-up window come out, maybe after or directly when you insert your card into the ATM machine. At one point of time, it will ask your 4-digit PIN number. Instead of 4-digit PIN number, if it asks enter 11 digits of account number, you may feel that it's better to go to bank for withdrawing money. Not everyone, maybe not like that. But when comparing with entering 4-digit PIN number with 11-digit account number, which one is good to you? In a general perspective, a 4-digit PIN number can easily remember. What I'm speaking is here, the end user, instead of the digital numbers, if he is provided the data with the land cover, that will be more useful to the end user. Am I right? Now, let us see the definition one more time. The process of extracting information classes from a multi-band raster image called as image classification. Extracting classes. How can I extract classes? How can I give that number W, water, urban? How can I give? That we are going to discuss. That's what about image classification. It's a procedure to categorize all pixels of image automatically into land cover classes is called as image classification. See, then why we are using this? To create thematic maps. What is thematic map? Theme. It's a theme. What is the theme in the sense? See, theme is one particular task here. Thematic, different types of, prepare a thematic map for the roads from the given topo sheet. Prepare a thematic map of roads from the given topo sheet. When you have a question in your laboratory exams, from the given topo sheet in the sense map, you must only give the information of the roads. That means here in this example, the roads are, the preparation of road network is the thematic map of roads. preparation of thematic maps, it will be useful. And that's why, and the last point just now seconds back I shared with you, as the satellite data is in a manner of DNs, digital numbers, we need to classify the data to be useful for the end user. And it is the prime objective of the, which is the prime, which will be the prime objective of the image classification. Understand? Did you understand? Right. We'll move to the next slide. See here, category classes means whether the pixel consists water area, vegetative area, soil area. We have seen here. See here, water, W represents water, forest, urban, like that. See here, classification means whatever the objects present on that particular area which has captured as an image. We are just simply depicting the classes names. I just given category classes means either water, vegetative, soil, road, forest, so on. See, based on the spectral reflectance, we can provide information what the pixel represents. See, based on the pixel, see here, based on the pixel resolution, see here what is based on the pixel representation, pixel resolution, we can represent what type of class it is. Is it possible? Unless we are not having the data which is supporting our decision. Our decision in the sense somehow, this 56 I can say it is water. How can I? Unless I'm not having the supporting document, how can I conclude this 56 is the resolution of digital number 56 is a water body? How can? And go to the point what we discussed here. Based on the spectral reflectance, we can provide information what the pixel represents. Is it possible? It is possible. How can? See, this is the FCC of one particular map. I just trimmed it for your understand purpose. Here it is FCC, false color composite. In the previous session we have seen, where you may not observe any legend here. The true color map is here. See, from this FCC, we prepared this and we are indicating the red build-up land and yellow is cropland and green is dense forest, like that. But in the FCC, you may not observe. But here we are just classified. How? This is what we will get in remote sensing applications. Through this, of course, not all the satellites we may get FCC. True color composite is there, Landsat we have seen, FCC is there, we have seen in spots for spot satellite specifications. See here, we have to have the knowledge while we are assigning classes of the map. How can we assign the classes? We are going to the next slide. Have a look here. This is the total process of image classification. Image classification has been divided into two categories. What is image classification? It is a process of assigning pixels into respective classes of land cover is called as image classification. Understand? It is a procedure of assigning pixels into definite classes of land cover is called as image classification we have seen. Now, this process has been divided into two categories. Spatial pattern recognition, this is nothing but spatial image. See here, the image is in the pattern of spatial resolution, spatial recognition, as it is the satellite image. It has been divided into two categories. One is supervised classification, the other one is unsupervised classification. Both these two classification will be done with the help of computer only. See here, before that, today we are going to first we'll discuss about supervised classification, and then we'll go to the unsupervised classification. Here, three stages we are finding: so training stage, classification stage, output stage. Training stage, classifiers in the sense classification stage, output stage. Types of image classification. The first one is supervised classification, where the entire process has been divided into three stages. First one is training stage. Here, the analyst identify the representative training areas and develops its numerical description of the spatial resolution. Right. See here, the analyst. Who is the analyst? The one who is interpreting the images. See, he will identify the representative training areas and develops its numerical description. See, how can he develops numerical description? Keep in mind, the analyst identify the representative training areas and develops numerical description. Keep in mind, have a word numerical description. What is numerical description here? For suppose, when we go to the image, digital image, see here, the analyst identified representative training areas. Here we would discuss, and we would discuss about a few points. The analyst who is interpreting, the basic eligibility is he has to know the information of the particular image in the realistic condition also. What is the eligibility? How you entered into KHIT? After your intermediate. If I said MSET, somebody may said, without MSET also I can do BTech, something like that. After your intermediate, of course, here also you may have a number of questions here. After your intermediate, in a normal way, through MSET, you are entering into the course BTech. That means the eligibility is intermediate and MSET, most of the cases. Now, what is the first eligibility of analyst? The analyst has to have the knowledge which is actually existed in the location, whose or else which image, or else for which location image he is trying to analyzing. Did you understand? One more time. The analyst has to have the knowledge of the realistic location information, for which location is trying to analyze with the help of image. That means he knows that this particular corner, I know because I know that area, the particular corner is water body, and this particular corner is again water body. That means based on his knowledge of the existed conditions of the realistic location, he will develop the numerical description. That means the digital number 56 represents water. How can he say? He know the information in that particular corner there is a lake, because he know the exact location personally. That means through field survey, through aerial photographs. Understand? See here, when we have a look here, field survey, training stage, maps, aerial photos, analyst knowledge. So based on his knowledge, he is able to define the class to that particular digital number digital number as it is located at that particular coordinate is give to the class water if it is the water. And similarly he used to find out the resolution of digital numbers wherever the water bodies are there. For suppose he found in this particular band, he found the 56 resolution belongs to water body. In the next band, that means the remote sensing image will be stored in 3 to 4 bands. We have seen the digital image picture earlier. In this band, the 10 represents water body. So 10. He has seen the next band of electromagnetic spectrum of the same image. There he found the digital number as 50. For the same image in the third band, he has seen the water bodies existing in 12 digital number and fourth is 80. That means he will give the numerical description as 10 to 18 may consist water body. Am I right? How can he form numerical description? As the first band, first pixel, he know that in that particular corner water body is there. 10 is the digital number value. In the second band, 13. Third band, 11. 14 band, so fourth band, 18 is the number. That means from the digital number 10 to 18 is water, numerical description. That means he has given, once he will give the algorithm that, the digital numbers whichever lies between 10 to 18 equal to water body, simply it gives water. In wherever the digital numbers lies between 10 to 18, at the output stage it goes or it converts as the cover name W. The same way for all the classes, he will find out the resolution of digital number for all the 4 bands and he will form the numerical description and he'll give the land cover name at the end. And in that particular area, these are the classes in that particular area. Which area is in the image mode, that is this image. Based on his knowledge, he'll find out the resolution of the digital number at that particular point for all the bands and he will develop the mean numerical description. Once he has given given the algorithm, automatically it converts into the class's name instead of the digital numbers at output. This is about the training stage. What is training stage? The training stage, the analyst has identified the representative training areas. How can he identify? See, based on the field surveys, maps, aerial photos, and his own knowledge. Representative training areas and develops its numerical description of the spatial resolution of all the bands. While he'll pass the mean value 10 to 80 represents water body and the same will be in the output mode. It will come in here as water body. For this training stage, there are certain limitations. What are those limitations? See here, the first one is he has to get the information about the complete location of the image. He has to have complete and full-fledged knowledge of the location, whatever the classes are existed, whatever the features are existed in the location. If he should find out at least 50 classes, if based on the area, the number of classes will be there. He has to represent maximum number of classes without leaving any type of class or category. If he missed any attribute, the image won't give the accuracy. Did you understand what I said? In one particular location, vegetation is there, soil is there, and road network is there, and water body is there. And one more thing is somehow he found some other attributes, one buildings are there. If he covered all these four, if he forgot the building in that particular location of the image, the information is inaccurate. Am I right? He covered all the features except one particular location. He covered vegetation, roads, soil, and water bodies, but buildings are not covered. That means what I'm speaking is here, the analyst has to cover all the classes of the study location. Then only he'll get the command on the image when he is preparing numerical description of respective classes. Next one is number of training sites, maximum number of training sites. That means each training site represents one class. All the classes, whatever they existed on the, domain, on the image, he has to interpret with the name of land cover. That's why in the first point I said it should cover the entire area and number of training sites must be selected and time of classification here. For suppose this classification has done during the early rainy season, based on the resolution he found in the exact location, there was nothing, only seeding was done for wheat. By the time of closing rain, if he is taking the same image what he prepared at the time of early rainy season, in that season only wheat seeding has done, but the time of closing post monsoon, the wheat plants are grown up. In the first, at the time he is classifying the image based on the aerial photographs, in that particular time only seeding was done. But if the same classification image you want to know, you want to use it at the time of post monsoon, it is not matching, because by the time it reached the end of the rainy season, already plants are grown up. That's why the training site time, whenever these training sites are selected, and whenever the classification is done, at that particular time only this images has to be used. That means these three are the limitations. The analyst has to have the knowledge, and number of training sites must be selected, and the time of classification, whenever the classification is done, to that particular time only this classified images will be useful for interpreting or to get the information of that particular location. Next one is classification stage. See here, the classification stage, there are different classifiers to classify the remote sensing images. They want perfect and most accurate classifier has to be selected to classify the image. When you are writing exam, you may be cautious that your pen is well writing before you are attending exam itself. If it is not writing well, you may not select it. If the classifier is not up to mark, you may not classify the image accurately. What I am speaking and stressing is here, as the pixel resolution almost similar to each other, for one particular class, sometimes these pixels are not similar to any of the training, a data set. What can you name it? What you can call it? Did you understand what I said? Once you have given the algorithm, all the pixels are turned by following the numerical description. 10 to 18 resolution digital numbers are water. If any pixel is not covered with the class name, that is unknown. But that unknown also has to be interpreted. We'll discuss what is what. The classification stage. In this classification stage, after the numerical description categorized, all the pixels are covered or else gives the information of the classes. If any pixel not comes under the given numerical description, it will be named as unknown. Third one is out. We will see what is classifier. We'll see next slide. Now we'll finish the stages. Output stage. The result will be like this. The result will be maps, tables, digital data files like this. And this is the input to GIS. This is the input to GIS. Classification stage. Here we are discussing. Somehow we have done the classification. What is happening in classification we discuss. The first stage, training stage, classification stage, output stage. Classification stage in the sense, based on the numerical description, all the pixel values comes into the name of the respective classes. And if the pixel is not similar to the numerical description, it will be named as unknown. See here, that will be named as if the pixel is not similar to any of the training data set, will be named as unknown. Now we'll see what is the classification stage, what happening here. There are, to classify the images of remote sensing, there are different classifiers. Among them we will discuss two types, that is good as per the subject point of view and guidelines curriculum point of view. See here, there are number of classifiers. We'll see one after one other. See here, classifiers we mentioned two. There are different, but two is enough. See here, minimum distance to mean method. Now we'll see here. Let us consider the image that has stored in two bands, band 1 and band 2. The digital, based on the digital numbers, all the brightness values 10 to 15 comes under class C, and all based on the digital number, and based on the other algorithm, class A, class B. Once we given the algorithm, there might be an occurrence of certain pixels which won't come to either of the any category here. In such cases, this resolution is not matching to any one of the class here. In that particular point, how can you classify this particular point of digital number? That means from the cluster of class C, all the digital number the digital number, the mean of all digital number values, if you got that digital number here, from here to here, you will draw a line. That means you are measuring the distance from here to here. What is this here? See, mean of the values obtained in the training phase. All the distant number mean value you found here. From here, wherever the place the pixel is unidentified, you will draw a straight line from the mean value distal number point to the unspecified pixel point. The same way, the neighboring from the neighboring classes also, you will find the mean value of all the digital numbers of that particular class, and wherever the mean value digital number comes from that particular point, you will draw a line to connect the unidentified pixel. The same way from the class A digital number mean value also. After you are measuring the distance, whichever the short distance, or else the pixel which falls under the shortest distance of the class, that will comes under to that particular class. If it is near to class A, this is also called as class A. If it is very near to class B, it is also classed as class B. If it is near to class C, this is also called as class C. What is class A? Water. Class B? Vegetation. Class C? Soil. If the distance is near to water, it is also called as water body. Water. In that particular area, water is there, you'll mention W. Remember the first map we have seen here, like this. If it is shortest to class B, vegetation, it is also named as vegetation V. If it is short to soil, it is also known to soil. Did you understand? Minimum distance to mean method. In this method, the mean point in digital parameter space will be calculated for the known pixel classes, and the leftover unknown pixel will be assigned to the class which is arithmetically closest when digital number values of different bands are plotted. Did you understand what I said here? Whatever I said here, I wrote here. See here, we are given the algorithm after identified all the training sites, but somewhere one particular location, the space is not matched to any of the algorithm we have given, numerical description we have given. In that particular point, we will find out the mean values of the all digital numbers of that particular class. We will write down, we'll draw a straight line to that particular location. Whichever the shortest distance from that particular group, this will comes under that particular group. It is about the minimum distance to mean method. Next one is parallel piped or box classifiers. Parallel piped or box classifiers. Simply nothing is there here. In the previous instance, if it is the unknown number is here, from here we used to draw a straight line. Likewise from here, from here, from here. But in this box mode, a box will be drawn by covering all the similar pixels. The unknown pixel comes into whatever the box that will be categorized with the class of that particular box, for suppose. Here H, maybe let us think that H in the sense hydro body, maybe H in the sense water body, U in the sense urban body, urban areas. See here, in the previous instance, we used to give a straight line from all the classes to unknown areas. Whichever the shortest distance, that will comes under to that particular class name. But here, a box will be drawn by covering all the similar pixel resolutions or as training sites into the box to which the unknown pixel comes. The unknown pixel will be named with the name of that particular class. Understand? If it is the water body, as it comes under water box which covers water body, it will call as water body W. It is fall under urban area. It comes under urban area. So it is also, even though the pixel resolution not matched to the other digital numbers, it is as it is near and that is comes under this particular box. It is also named as urban body. This is what about parallel piped or box classifier. This is the simplest of all classification method. A set of k-dimensional boxes centered at the estimated class and placed in those boxes. I mean, estimated class mean vectors are placed in those box space. If we unable to see whatever I discussed here, the same I wrote here. If any unlabeled pixel lies within one of the boxes, it is assigned to that respective classes. But here you may have a doubt. There it comes under the group whichever having shortest distance from that particular point. But here simply which it will be named as per the box to where it to which box it is located. The box's name, the box cover name will be allotted to that unknown pixel. But in the previous case, the distance is the parameter. Here the box is the parameter to give the class name. There might be a misinterpretation sometimes. That is the reason we'll go for the accuracy test to identify exactly what it is after given the classes names to for more information. Did you understand what I said? We'll go for accuracy test to overcome the miscommunication, misinterpretation. This is what about supervised classification. And here we discuss three stages are there. Training stage, which will be done with the help of field surveys, maps, aerial photos, and analyst knowledge used to identify the locations, name of the attributes that are existed in the location. Based on his knowledge, he will assign the numbers by understanding the or else by understanding the digital by understanding pixels of that particular location based on the coordinates. Likewise, he used to identify all the bands resolution for one particular image, all the bands in the sense in remote sensing, band 1, 2, 3, that means visible band, red, green, blue, and infrared band. These four bands are more favorable for remote sensing applications. He used to compare the band. What is the band? You know, these are the bands 1, 2, 3, 4, 5. He used to identify what it is. As he know the information, here is a water body because he is well aware of that particular location. He used to identify all the bands at this particular location. From the digital numbers of all those bands, he will form numerical description. Based on the numerical description, once he'll give the algorithm and he'll the classes names will be find out as an output will get the information instead of digital numbers. The name of the classes will be given, which will be used, which will be in the form of tables, maps, digital data files. I said that the output of remote sensing is input to GIS, and this output will be used as an input to GIS. See here, Today we have seen what is supervised classification, training stage, and the limitations. Complete study of location has to be done by the analyst, either any one of the mode, through maps or else through field surveys, aerial photos, analyst own knowledge. He has to know. And next one, number of training areas. He has to cover all the attributes by giving number of training classes or else areas. Time classification. Whenever he studied the location and whenever the classification is done at that particular period only, this image will be useful. I said and I discussed with classy example of weight at the time at the time of rainy season, initial stage of rainy season, starting of rainy season, the seeding where nothing was observed, the resolution with blank soils, empty soils, where at the time we reached the close to completion of rainy season, there the seeds are grown up. The resolution will be different. Based on the resolution, he has given the numerical description. That means there might be a occurrence of mismatch. That is the reason the classification images, these images has to be used at the time of classification itself, at the time when the classification is done only. Next one is classification stage. Once the numerical description has given, all the pixels comes under different respective classes. If any pixel is not similar to the numerical description, that will be named as unknown. What we can do that unknown pixel, we have seen the classifiers. In the classifiers we discussed about the unknown pixels. The last one is output stage. After the classification, the output will be in the form of thematic maps, digital files, tables, which becomes input to GIS. This is the schematic diagram of the supervisor classification. And next one is minimum distance. See, in this particular area, water, sand, forest, urban, corn, hay are there in this particular location image. The same will be appeared output as forest, W. W means water, S means sand, U means urban, C means corns, something like that. All the attributes will be displayed here instead of numbers, digital numbers. Understand? These are the digital number 1, 2, 3, 4, 5. Understand? Like this. Here now we'll go to the minimum distance to main method. In the minimum distance to mean method, this is the unknown identity, unknown pixel, and here to here, after all the numerical description, based on the numerical description, all the classes are formed to that unknown pixel. When straight line will be formed, and the straight lines will be measured to whichever the shortest distance to the group, whichever the shortest distance from the unknown pixel, this pixel comes under to that particular category. This is what about minimum distance to mean method. Parallel pipe method, instead of distance, we are just making boxes to whichever the box the unknown pixel comes under, it will be named with the particular box class name. This is about the supervisor classification. If you have any doubts, you are more welcome and you are most welcome. You can contact me at whatever the domain you feel convenient. Thank you. We'll meet in the next session.